Hi, my name is Krishna Kumar Singh. I am going to start lecture on the 3-4-5 triangle for trigonometry. So this is especially for use of the machines of calculation in the field of the CNC machining area. So before we delve into the more technical aspects of solving triangles, let us discuss the 3-4-5 triangle. So now introduction of the 3-4-5 triangle. The 3-4-5 triangle is a right angle triangle with sides of lengths 3, 4 and 5. This set is the smallest possible whole number set that forms a right angle triangle. It is widely used in various fields, particularly in the building industry, to create accurate right angle corner. So now practical applications. In practice, if you draw a 3-meter line along one wall and a 4-meter line along another wall, then link them together with a 5-meter line, the angle between the two walls will be exactly 90 degrees. This method is very helpful when accuracy is crucial, such as in construction and carpentry. Used in trigonometry, the 3-4-5 triangle is also useful for verifying calculation in trigonometry. When working with trigonometric problem and formulas, applying them 3-4-5 triangle can help confirm whether the solutions are correct. Since properties and side length of this triangle are well known as consistent. So now is the scalability. Another significant figure of the 3-4-5 triangle is its scalability. The ratio of the sides 3:4, 4:5 can be multiplied by any number to create a large or a smaller triangle with the same properties. For example, so multiply each side by 2 result in a 6, 8, 10 triangle. Now multiply each other by 1.5 result in 4.5, 6, 7.5 triangle. Regarding of the scaling, as long as the sides maintains the ratio of 3:4, 4:5, the resulting triangle will always be right angle triangle. So now come to the conclusion. To summarize, the 3-4-5 triangle is an essential concept due to its simplicity and practical applications. It helps ensure accuracy in construction and provides a reliable method for verifying trigonometric calculation. So remember, it must always be a right angle triangle and the side must adhere to the ratio of 3:4, 4:5. So now let us start. Before we look at trigonometry, to solve our triangle problems, we might be able to use Pythagoras theorem instead, and it might be a little bit simpler than going straight into trigonometry. In this lesson, we are going to take a look at Pythagoras theorem and how are we use it to solve our triangle. So now introduction to Pythagoras theorem. So Pythagoras theorem is a fundamental principle in geometry that help us determine the length of hypotenuse or even another side of a right angle triangle if we know the length of the other two sides. This theorem only applies to right angle triangle. So naming the triangle parts, let us name the part of our triangle. The shortest length is called A, the base length is B and the hypotenuse is C. We will use this naming convention to work out the length of the hypotenuse. To calculate C, we need to know the length of A and B. So Pythagoras theorem states a square plus B square equal to C square. This is a very simple equation that allows us to find the length of the hypotenuse. Graphically, if we take the length of hypotenuse and square it, the area of this square will equal the sum of the areas of the squares on the other two sides. So now the example of the calculation, let us use some number to make this clear. Suppose the left hand side A is 3 and base B is 4, we need to find the hypotenuse C using Pythagoras theorems, a square plus b square is equal to c square, then 3 square plus 4 square equal to c square. So 9 plus 16 is equal to c square. So c equal to under root 25. So c will be equal to your 5. So if we know two lengths, we make work out the third length using Pythagoras theorem. In this case, we have created a 3, 4, 5 triangle. So now graphical representation. To visualize this, if we draw a square on each side of triangle, the area of a square on side A, B will fit perfectly into the square on hypotenuse C. For A equal to 3, the square has 9, and for B equal to 4, the square has 16, and for C equal to 5, the square is 25. So finding other sides, we can also rearrange Pythagoras theorem to find the other sides if we know the hypotenuse and one another side. For example, to find B, if we know A and C, C square minus A square is equal to B square. 5 square minus 3 square is equal to B square. 25 minus 9 is equal to B square. 16 is equal to B square. B is equal to under root of 16. So B is equal to 4. So thus, using the basic transposition of Pythagoras theorem, we arrive back at our 3, 4, 5 triangle. So now the conclusion is, if we know two lengths of right angle triangle, we can work out the third length using Pythagoras theorem. This does not cover all triangle issues. Of course, for other cases, we would use trigonometry.